Reading Comprehension C1-C2. Lesson 6. The Periodic Table. Understanding the Elements of Matter. Let's begin.
The periodic table of elements is one of the most iconic and fundamental tools in science, representing the building blocks of all matter in the universe. It organizes chemical elements based on their atomic structure and properties, providing scientists with a framework to understand the behavior of matter. Created by Russian chemist Dmitry Mendeleev in 1869, the periodic table has since been refined and expanded as new elements have been discovered. At its core, the periodic table arranges elements in order of increasing atomic number, which refers to the number of protons in an atom's nucleus. This simple ordering reveals patterns in the properties of elements, such as their reactivity, conductivity, and the types of bonds they form. Elements are grouped into vertical columns, called groups or families, and horizontal rows known as periods. Each group contains elements with similar chemical behaviors, while the periods represent different energy levels of electrons. One of the major breakthroughs of the periodic table is the ability to predict the properties of undiscovered elements. When Mendeleev first designed his table, several gaps existed where no elements were known, but he correctly predicted the characteristics of these elements based on their position in the table. Over time, elements like gallium and germanium were discovered, confirming the predictive power of the periodic table. Elements can be classified into metals, nonmetals, and metalloids, with metals being the most abundant category. Metals, such as iron, copper, and gold, are generally shiny, conductive, and malleable, making them essential for tools, construction, and electronics. Nonmetals, like oxygen and carbon, are more diverse in their properties but tend to be poor conductors and are found in gases and organic compounds. Metalloids, such as silicon and arsenic, have properties of both metals and nonmetals, and play crucial roles in industries like electronics, especially in semiconductors. At the far right of the periodic table are the noble gases, a group of elements known for their lack of reactivity. Elements like helium, neon, and argon are inert under most conditions because their outer electron shells are full, making them unlikely to form chemical bonds. This stability contrasts with highly reactive elements such as the alkali metals in group 1, which readily lose an electron to form compounds like sodium chloride, table salt. Another significant feature of the periodic table is its ability to explain atomic bonding, the process by which atoms combine to form molecules. Atoms bond to achieve stable electron configurations, often by sharing or transferring electrons. Covalent bonds, in which atoms share electrons, are typical among nonmetals, while ionic bonds, formed through electron transfer, are common between metals and nonmetals. The periodic table continues to evolve as scientists synthesize new elements in laboratories. The heaviest elements, such as those in the superheavy category, do not occur naturally and can only be created through nuclear reactions. These elements often exist for mere fractions of a second before decaying, yet their discovery pushes the boundaries of scientific knowledge about atomic structure and stability. The periodic table not only serves as a practical tool for chemists and physicists, but also symbolizes the quest to understand the fundamental nature of matter. Its structured layout tells the story of the universe, from the hydrogen atoms formed shortly after the Big Bang to the complex elements forged in the cores of stars. As scientists continue to probe deeper into the mysteries of the atomic world, the periodic table remains a crucial guide in unlocking the secrets of the elements.
Thanks for watching. Visit www.TutorUKABC.com for more fun learning material.